Welcome to the podcast, Deserts to Grasslands. I'm your host, Sherry Minnelli, and we're exploring how to green the desert. We're also exploring how to stop desertification. And I think that you'll find this podcast to be incredibly positive and hopeful. We're going to introduce you to Roger Savory. Roger Savory isn't as well known as his father, Alan Savory. Alan, of course, is very famous for starting holistic management and writing all the books on it. And he also has the most fantastic TED Talk, one of the most popular TED Talks out there on desertification. And I'll put a link below as well. But back to Roger. Roger isn't as well known, but he has done some really incredible projects all over the world. Australia, Africa, Canada, the US, and other places. And we're going to be exploring some of his techniques and methods. And we're also going to be following him and his team because they're competing for the X Prize for carbon removal. And one of the projects is out there in the Salton Sea, which is southeastern California, with a huge salt lake that's drying up like crazy. And there's another project that they're starting in New Mexico soon. So we'll be documenting all of that. I want to jump in and I'll introduce you to Roger through some of his projects. I'll drop you in here into an interview I had with him a few days ago where we were discussing the Salton Sea.
Thanks for doing this, Sherry. Thanks for having me on. Well, to be honest, I'm not doing anything in the Salton Sea. What I would like to do in the Salton Sea is a different matter. I moved to California about 5 years ago because I knew that we had to make a difference in the world, and no one was looking to Africa or Australia for world-leading ideas. Everyone looks to California. I partnered up with Kevin Muno down near San Diego, and then I started working with him up by Julian. But while I was up there, it was just 17 minutes over the hill to get down into that Imperial Valley area. I was absolutely amazed. It was as bad a desert as anything I've seen in the United Arab Emirates or Africa, but I clearly saw all the same things I see in those other locations. I then did more research. I studied the rain shadow effect. I studied the history of the Salton Sea. On my weekends, I used to go and drive around and just go and look. And the more I saw, the more I went, hold on, this doesn't need to be a desert. We've done this. And then a real piece of the puzzle came together when I found out about a flood roughly 100 years ago that was apparently catastrophic, but it killed the majority of the Californian cattle herd at that time, which used to be behind the mountains that make up the barrier between the ocean and San Diego and Los Angeles. And the majority of the cattle were there because it was better forage and better grazing. After the floods, when everything died, because there was 6 or 7 feet of topsoil that moved, and you can go out there and you can find the old barbed wire fences with just the top strand of wire still sticking up above the ground. Now, no one's going to build a barbed wire fence in a desert to keep cattle in, but they will build a barbed wire fence if there's abundant forage to keep cattle in. And remember, barbed wire was only invented in 1867 or thereabouts. So it's a relatively new invention. So it would have been an expensive new invention. Well, that tells a story. So about 2 years ago, we had a massive flood in Australia, and it killed several 100,000 cattle in one flood. But we got to see a modern version of what those catastrophic floods look like. When your whole paddock is suddenly 6 foot deep in water and it goes for hundreds of miles, everything gets washed down to the fence lines, everything gets caught on the fences, everything dies, and there is no high ground to go to. That flood 100 years ago was catastrophic. The people in the area died, so there was nobody left to tell the story. So the story didn't get out. The cattle died, the people died. We now know that in a brittle environment, when you rest the grassland, it dies and it goes to desert. Overrest kills it. So if we had had the bison and we removed the bison, then we replaced them with these big herds of cattle, and we were doing quite well with that, then a flood comes and kills all the cattle. But it's a brittle environment. Whatever grass grew after the flood then died because there was nothing to keep it alive. And I got hold of the old records from the first priests who walked through the area, and it was pretty harsh country. I read those records and I went, yeah, that makes sense. And then I looked at the pollen records from the salt pits and the tar pits and from the deep cores where they got the pollen records, going back 10,000 years. And you go, wow, there were willows here. No, but willows don't grow unless there's moisture. And you go through all these different plants that were growing there, and you read the grasses and you go, no, but those are African grasses. Those are the grasses that we have in our healthy grasslands in Africa. But the same species were growing there. And you go through all these lists, and this is all, the universities have all this data. You've just got to go and mine it out. And you start putting the piece of the puzzle together, then you go, okay, this is 100% a man-made desert. We made it. Okay, if we made it, we can fix it. It's taken us so long and the damage is so extreme, fixing it is not going to be cheap. It's not going to be easy, but it's mathematically and scientifically possible. So then I started looking around, and I looked at the Salton Sea area, and it's a massive area. There are millions of acres of really denuded ground. But due to irrigation, there's a corridor that comes down the middle of the valley. And it's irrigated and it's highly productive. And it's highly productive because it doesn't really have a winter. So they can have year-round growth. But it's purely dependent on the irrigation. They are having salinization problems because the evaporation causes the salts to rise up to the soil surface. When the salts rise up too much, then the soil becomes too salty and they can't grow anything. So they've got various tricks for trying to prolong the life of the irrigated land. But we know from the projects in Australia, in the Middle East, all over the world, that in these ecosystems, chemistry wins when you do irrigated croplands. And we're already starting to see some of the fields are being taken out of the rotation because they can't produce anything anymore. It's so slow that we don't notice it, but it definitely keeps happening. Now, the reason for that is normally you would have rainfall, 10% would evaporate and 84% would go deep down. And that's because the soil would be 100% ground covered. But when humans get involved, we plow and we keep 99% bare soil in between the plants, and then we have the plants. So now bare soil has 84% evaporation. So now all that water that we put on the soil, it soaks in, but then evapotranspiration pulls it back up to the surface. But now instead of only 10% evaporating, 84% evaporates. So it disappears back up into the atmosphere. But in the process, it pulled all those salts up. But the salts can't evaporate. Only the H2O can. So the water leaves and the salts are now up in the top 10 centimeters where the plant's roots need to be. So it does happen gradually. It's guaranteed. It's a mathematical certainty that it will turn salty and it will die, and you can plow the salty soil down deep, and you can buy time and at extreme expense, and they do all those tricks, and they can try and soak the field and then leach the salty water off, and we've got all these different tricks to lengthen the period before it's totally dead, but we don't have a trick to stop it other than nature and getting it 100% covered. And so then I thought, okay, I know how to get the ecosystem functioning again through a process that I developed a long time ago in Africa that I called biological carpeting. Tony Tipton in Arizona did a similar concept on mine tailings. He fed hay on mine tailings and got the grass to grow, and then the cattle got banned from the mine tailings. Just normal idiotic bureaucracy. We did it with the National Forest Service, same thing. Then the cattle got banned. People have been doing this for going on 30 years, but I really pushed the envelope of the knowledge. When I did 13 years of experiments, I finally, after 13 years, I'd figured out what was the key that I had to get right. In other words, I'd do an experiment and I'd get one result, and the next year I'd do the same experiment and I'd get a different result. And I couldn't figure it out, and I couldn't figure it out, and I couldn't figure it out. And then I thought I'd figured it out, and I got the same result. And then the next year I got the same result, and the next year. And then I went to Colorado and I tried it and I got the same result. And then I went to Canada and I got the same result. Then I went to Australia and I got the same result. So then I was like, okay, I've got it. I figured it out. But that whole process of trial and error took 13 years of my life.
And what is it that you figured out? Like, what are you referring to here?
Well, I call it biological carpeting, but in a nutshell, what I figured out was that the enemy was ultraviolet light. When you think about it logically, if you buy a bottle of, plastic bottle of water, they put the water in the plastic bottle and then they run it under an ultraviolet light to sterilize it. But we know UV light sterilizes and kills all the bacteria in our water. What do you think it's doing to our soil? Exact same thing. The top millimeter of microbes is the most important millimeter. If it dies, then the second millimeter can't establish. So if we can't protect that top millimeter, nothing else can happen below. It's got nothing to do with the nutrients. Only thing that matters is protecting the top millimeter from ultraviolet light.
For people who don't understand, what's the difference between a biological carpet and the slurry?
Slurry, by the definition, it sounds like water. Okay, so it soaks in and it disappears. The biological carpet basically it's biology. It's been through the intestine of a grazing animal, so it's full of life. It's also full of fungi spores. Now, the fungi spores are the most important thing once we've protected it from ultraviolet light. Anyone, if you ask them, what conditions mushrooms need to grow, everyone will tell you warm, wet, and dark. In the desert sand, blowing hot 140-degree sand of the Salton Sea Imperial Valley area, where are you going to find warm, wet, and dark? One in the intestine of the grazing animal, in the gut. It's warm, it's wet, and it's dark. The only other place will be under the biological carpet, because the biological carpet's got to be thick enough to hold the water, dark enough to stop the light, and then the heat is there in the valley, so there's your warm. And warm, not boiling, not baking hot. Okay, so the biological carpet that I finally figured out had that combination of warm, wet, and dark. When we started figuring out how to get that biological carpet onto a piece of land, now we started always having success.
So are you saying that the biological carpet has to be on every inch of that land?
Yep.
It can't be just a spot here and a spot there.
No, I get it on every inch of the land.
And what happens if it was just a spot there and then a few feet away, a spot there?
It doesn't work because the evaporation happens away around it. So the moisture gets sucked out from around it. A cow drinks 10 gallons of water a day. Now, if I've got 10,000 cows together giving me my biological carpet, so they'll drop, call it 25 pounds of biological carpet on the ground. So 10,000 times 25 pounds, 250,000 pounds. And then they also have to urinate. So on top of that carpet, then they add 10,000 cows times 10 gallons, 100,000 gallons of irrigated water goes through the carpet. And because it goes in and then can't evaporate, and only 10% evaporates, the rest is that moisture.
So isn't urine considered salty?
Yeah, I mean, it's perfectly balanced.
So it wouldn't salt the desert more?
No, if it was on bare sand, it would.
Oh, so if you just wanted to like spray urine somehow on that sand, you would get more salt.
Yes, which is what the dairies do. They take their ponds and then they mechanically go and spray it on the fields, and we don't get a good result. So you can see all of this mechanical thinking, all these little pieces of mechanical thinking. No one's ever tried to connect all the dots. I think I'm the first person who connected the chemistry to the biology, to the fungi, to the seeds. I'm the first guy who pulled all these multiple parts from numerous different fields of study into one picture.
Let's put this all together. What does that mean? What could you go do in those desert areas with cows? What would you be doing?
So the biological carpet is just to jumpstart the life cycle. Once the life cycle has been jump-started and it's able to get started, get out its way. It's on a roll. I came up with a saying, and it basically goes like this: life begets life, more life begets more life. Now, I know begets probably came from my Shakespeare studying, but no one uses it anymore, but I can't think of a better word. When we're able to get that life in that top millimeter, it begets more life, which means the second millimeter has life. And the second millimeter has life, so it begets more life. So the third millimeter has life. And it begets, and da 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 da. And now you go from tiny little bacteria, microorganisms. And now you get a bit of fungi going. And now you get a nematode going. And now you get an earthworm going. And now you get a whole full-blown mushroom going. And now you get a plant germinating and starting to grow. And now it's photosynthesizing. And now it's pumping sugar under the ground to feed all this life. And now you've got the cycle beginning. So you've jump-started the life cycle. But it started with needing to protect that top millimeter, having the warm, wet, and dark, which encouraged the mycelial networks. This is a fascinating thing I found out some years ago. Most of the seeds will not germinate until the mycelium has tapped it on the side and said, hey, knock, 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 knock. Hey, it's time to germinate.
I hadn't heard that before.
Well, you had, because you've heard you've got to buy inoculated legume seeds, right?
Right.
What's an inoculation? It's a fungi.
Cows have this amazing stomach and can do all this. Can any other animal, or is it just cattle?
No, it's basically any grazing animal. So in Africa, I used to run sheep, goats, and cattle, and pigs and chickens and horses and everything else. But what I noticed was my biological carpeting, where we had the sheep and goats, the plants grew the best with sheep and goat manure. And the plants didn't grow as well in the cow manure. There was more nutrient in the sheep manure. Okay. However, the first time we had 4 inches of rain, all the little sheep pellets and goat pellets floated up to the surface and off they went down the river. Whereas the cow paddy had plopped flat on the ground and locked itself into position. So what I learned was the best was to have 50-50, to have the cattle and the sheep and goats, so the sheep pellets could get stuck in the cow manure.
So do you run one ahead of the other? Do you do the sheep and the goats first and then the cows after it? Or does it matter?
It's all in what you can do and what you can get away with. When a cow stands on a sheep's leg, it breaks its leg. We just got tired of having sheep and goats with cattle because, I mean, we were always being Doctor Who and putting splints on legs. The compromise I came up with to get that same kind of nutrient density and everything was to run chickens with the cattle. So the cattle had the plop that went plop, the chickens scratched through it, and their feces is very high in nitrogen. It wasn't as much as the sheep and goats, but that was a kind of a compromise. But if I was to be in like one of the Middle Eastern countries doing this, I would probably doing it with 75% sheep and goats and 25% cattle, just so the cattle are there to lock everything in place, but the culture eats sheep and goats. Here, our culture mostly eats cattle, and there's a huge demand for it, so I probably wouldn't even bother with sheep and goats.
Okay, and then what about bison?
Well, we just don't have enough bison. I mean, I'm friends with a lot of the bison ranchers in America, and we've got some lovely bison herds, but you remember they were nearly extinct. So most of the bison that you see aren't actually buffalo, they're beefaloes. They're a cross.
Oh, really?
And then the real bison, they're really rare. And the reason that was done was there were so few females that they just put bison onto cattle to try and get their numbers up. But yeah, pure genetics bison, very small. Mostly still owned by governments. There's a herd up in Alberta, and there are a couple of pure herds, but they are more rare than the crossbreeds.
So let's just say that you have a piece of land and you run the cattle through this out by the Salton Sea, the Imperial Valley, it's all mostly sand. How long would it take for us to notice a difference?
The fastest I ever had a result was 2 weeks. Now, okay, that's the teaser, that's the bait. Okay, so let me explain what happened in that 2 weeks. So we did the biological carpeting, and then the cattle had moved off and the sheep and goats had moved off. And then 2 weeks later, this was in the dry season, and we have a 9-month dry season in Africa, and it's quite brutal towards the end of the 9 months. We're hot, we're bothered, We were frustrated. October's called suicide month because we don't have air conditioning over there. It's miserable. And 2 weeks before the rains, we did a biological carpet on a really, really bad piece of land. When I say bad, it was just shale rock. There was nothing there. And so we did the biological carpet there. Then 2 weeks later, it rained. And it was the most amazing thing I've witnessed in my life. Because we did it right on our entrance road, so you had to drive past it twice a day, coming and going from the ranch. You couldn't not notice it. And the rains came, and the first thing that happened was all the dung on the soil surface disappeared. We were like, what? And it all disappeared, and it all got replaced with red sand. And we were like, but it's shale here. This is gray shale. Where the hell has this red sand come from? And I don't know how deep it was or what angle it was, but about 100 yards away was a red sand dune. And so I don't know what was happening in the formation under that. But basically, the dung beetles took all the dung and buried it. As soon as it was wet, the dung beetles buried the dung. And then they brought the dung disappeared, and this red sand came up to the surface, kind of like giant earthworm mounds. And then a couple of days later, there was just mushrooms over the whole area. But I'm talking tiny, teeny, the most microscopic little mushrooms, to big mushrooms, to blue mushrooms, to orange mushrooms, to yellow mushrooms. I have never seen so many mushroom species in my life in any one location. This was 100 meters by 100 meters of solid mushrooms. If I had to guess, I would say I saw 10,000 species of mushroom. I have no idea what I witnessed. It was overwhelming. But the sad thing is I didn't even get to collect data on it, and I didn't even get to take samples because at that time I didn't even know much about mushrooms. And I was more sitting in shock going, what have I just witnessed? And then all the mushrooms, it was pretty hot after the rain, all the mushrooms shriveled up and gone. And then next day I'm driving out and I look over and it's just this green chia pet. And you know the advert, all the green shoots, whole area was a green chia pet. And there was these thousands upon thousands of grasses and whatever germinated. And then those started growing, and about 6 weeks later, we had shoulder-high grass. Now, the most amazing thing about that whole process for me was we had about 200 women who used to come in from the villages to come and cut thatching grass and work on the ranch. This was the end of the dry season, so they'd already cut all their thatch, but they were combing their thatch into 4-inch bundles and getting it ready for the sale. Because of poaching and all of that, I always insisted that they walk in a group, come down the road together so that our game scouts could make sure no one was sneaking off and setting snares. And well, one day I just happened to be going up the road as this group of women were coming down, and one of these old women, she must have been about 80 years old, she just went into her full-blown African traditional and just started screaming and yelling and dancing, and she grabbed a whole bunch of like the 10, 12-year-old girls and rushed them into my biological carpet area. And she said, and she basically in her language, she said, this is the grass we were telling you about. This is the grass that we used to make our bridal baskets out of when we got married. This is the grass I haven't seen since I was a child. I tell you what, that kind of stuff gives you chills.
Where was this?
Zimbabwe, at the Africa Center for Holistic Management. But what that then told me was that, hey, these seeds stay in the soil and they wait for the right conditions to germinate. So the right conditions had returned there, the mycelium had triggered it, and it had germinated and grown. If we can protect that top millimeter from ultraviolet light, and if we can hold the moisture on the soil so whatever moisture does fall can keep the mycelial networks going, and they don't need much. I mean, we've got some mycelium that pump water from 30 meters, 90 feet underground back up to the soil surface. And then they trade it with plants for the energy that the plants get from the sunlight. There, the Salton Sea, the water isn't that deep.
So what do you need now in the Salton Sea to be able to do this project? And once you do this project, do we have any idea how many acres we need to, make a big change in the watershed?
So there's two places in the world where a rainfall changed as a result of vegetation changes. One is in Zululand, South Africa, where the Sappi forest was, and the other is the Midwest of America in late summer. Now, the late summer in the Midwest is when the corn is all big and tall and lush. In the early summer, the Midwest rainfall's actually gone down, but in the late summer, it's gone up. And it's absolutely to do with evapotranspiration and the micro water cycle. And the same thing with the Sappi, where it was grassland and they planted trees. Now, when I was studying those figures, I looked at what point did the rainfall start increasing. Sappi's got a couple of million acres now. The Midwest is several million acres. But at what point did the weather start changing? And we didn't see a weather change until about 150,000 acres was planted. So in my mind, that's kind of a key figure now, because the only two experiments in the world that have shown it was 150,000 acres. Now, there is one exception to that rule, and that's 7,000 acres in Brazil. That was completely replanted to trees. I think they planted about 2 million trees on that ranch. And that has also changed as well. It used to be a rainforest. They cut the rainforest down and have replanted it, and it came right. But I'm not counting that because that was already a rainforest. It was just a non-functioning water cycle. The 150,000 acres is in the brittle environments where the precipitation had dropped and where the precipitation in the micro water cycle goes up. So in my mind, I want to start with 150,000 acres. Now, obviously, you start with 1 acre. I want to get to 150,000 acres as quickly as I can. And it sounds a lot until you realize that cactus feeders in Texas have about 500,000 cattle in their feedlot. And based on my calculations, we'd only need 700,000 to get a biological carpet over 150,000 acres in 1 year. With all the resources available in America, it's highly doable. We've probably got that many cattle in feedlots in California right now, and the feedlots are CAFOs. They're poisoning the water. They're unhealthy. They're feeding grain to livestock that should, I've yet to see a cow with a beak. We could just repurpose our current feedlots and turn them into, grass finishing feedlots with biological carpeting. And this is what's so frustrating. It would be so easy to just repurpose what we've got and to turn the deserts back into grasslands, but let's do it. And so I'm hoping that, the world can assist me to do 6,000 or 5,000 acres to get started, and just to iron out the kinks, to figure out, I hadn't thought of that. Okay, let's fix that. I hadn't thought of that. Let's fix that. Because you can come up with the best laid plans of mice and men, but it's nature we're dealing with.
And that's the end of this interview. I've got so many more hours of information from Roger and other people that will be coming up in upcoming episodes. If you'd like more information on our project, go to fixdeserts.com.